Hello everyone and welcome to 30 Days of Java. It's day 20 now and today we'll be discussing about collection framework in Java. In this video we'll learn about what a collection framework is and why is it used. Then we'll see the hierarchy of Java's collection framework and finally we'll take a look at the list interface and its implementations. So let's begin. The collection framework in Java provides a set of interfaces and classes to represent and manipulate collections of objects. It offers a standardized architecture for representing and manipulating collections of data in a unified way. The main reason that we use the collection framework is it simplifies data manipulation, promotes code reuse, enhances performance, and provides essential tool for developing robust and efficient Java applications. Importing the collection framework in Java is pretty straightforward. Since the collection framework is part of the Java standard library, you don't need to explicitly import it. It is already available in the java.utils package, which is automatically imported into every Java source file. However, if you're using specific classes or interfaces from the collection framework, you might need to import them explicitly, as shown in the screenshot. Now that we know what a collection framework is, let's talk about its hierarchy. In the flowchart shown, the boxes in the blue represent interfaces and the boxes in green represent classes. At the very top, you have an iterable interface, which is a fundamental part of Java Collections framework. It represents a sequence of elements that can be iterated over, allowing access to each element sequentially. The collection interface extends the iterable interface, which is then extended by various other interfaces like list, queue, or set, which have different use cases and properties. Java's collection framework is a vast topic in itself, which is beyond the scope of this course, so we'll only discuss the important interfaces and implementations here. For this video, we'll discuss the list interface and its implementations. The list interface represents an ordered collection of elements that allows duplicate elements. Its implementation includes ArrayList, LinkedList, vector, and stack. Let's look at each one of them individually. ArrayList is one of the most commonly used implementation of list interface. It provides fast random access and is suitable for scenarios where you frequently access the element by the index. When you create an array list in Java, it internally allocates an array in memory to store elements. Initially, this array has a fixed capacity. Let's say it's set to hold 5 elements. As you add elements to the array list, they are placed into the array. Now let's say you have filled up your array list to its capacity of 5 elements, and you try to add another element. At this point, the array list needs more space to accommodate the new element. To do this, it allocates a new array with increased capacity. In most implementations, this new capacity is set to 50% more than the current capacity. So in our example, if the initial capacity was 5, the new array would have the capacity of 7, that is 5 plus 50% of 5. Then the array list copies all the elements from the old array to the new array internally, ensuring that all the existing elements are preserved. This process of resizing the underlying array and copying elements happens automatically behind the scenes whenever the array reaches its capacity. By dynamically resizing its internal array, ArrayList ensures that it can grow and shrink as needed to accommodate the elements you add or remove, providing flexibility and efficiency in managing lists of elements. LinkedList is a class that implements the list interface and represents a doubly linked list. Unlike arrays which store elements in contiguous memory location, a linked list consists of elements each containing a reference to the next element in the sequence, forming a chain-like structure. It provides efficient insertion and deletion operations, especially when adding or removing elements from the beginning or the middle of the list. Every element of the linked list is called a node, which has a reference to point to the previous element, another reference to point to the next element, and a data part which contains the main data as shown below. A vector is a legacy class that implements a dynamic array, similar to ArrayList but with synchronized methods, making it thread safe. Despite its thread safety, vector is considered somewhat outdated, and in most cases, ArrayList is preferred due to its performance in non-concurrent scenarios. However, vector can still be useful in certain scenarios where thread safety is a requirement. Let's understand stack with a simple example. Imagine a stack of books at a library. You can only add or remove books from the top of the stack. This is exactly how a stack data structure works in computer science. In Java, a stack is a collection that follows the last in first out principle, that is LIFO, meaning the last element added is the first one to be removed. It is like a vertical pile of items where you can only interact with the top item. It provides push and pop operations for adding and removing elements from the top of the stack. Now, let's try everything that we have learned so far on IntelliJ. Now let's first start by creating a simple array list of strings. So for that, we'll type in list, that is the name of the interface, then the data type, that is string, then the name of the object, that is ArrayList, then new ArrayList. Now one thing to note here is that we are using the interface name, that is list, as the data type for ArrayList instead of ArrayList, that is the implementation. We are doing this to make the code future-proof. So imagine in future I want to change the implementation of this ArrayList object from ArrayList to say LinkedList. Then I can simply go here and make the changes, and it would work without any hiccup. But if this part was ArrayList, it would throw an error. So this future-proofs the code when we are using the interface name instead of the actual implementation of the interface. I'll change it back to list and this back to ArrayList. Also, in production environment, we generally do not even use the name of the interface. We simply replace this part with var. Now var is a keyword that picks up the data type for an object automatically during runtime. The only requirement for using var is that whenever you are declaring an object with it, it needs to be initialized to some type of data type. Like in this case, we are using it with ArrayList. And since we have not passed in any data type here, it's giving back an array list of objects, as you can see here. If I change it to array list of string and then hover over it, you can see it changed it to array list of strings. Now let's change it back to array list of objects, and let's try adding some elements into it. So I'll type in ArrayList.add, and since we are using the array list of objects, I can type in any data type. So first I'll type in an integer, then I'll type in a string, and let's output them on console by using a for each loop. For that I'll type in for and then the name of the variable. We'll also use var here, and I'll simply call it temp and then ArrayList. The for each loop is a different variation of for loop. It is usually used when you need to iterate over every element of a loop. So it's basically a shorthand for writing a for loop. Then I can simply type in system.out.println and then temp. Now if I run this program, you can see it printed out 23 and hello. Now, as I have already mentioned, that for changing this ArrayList implementation from ArrayList to LinkedList, I simply need to make changes here. LinkedList, and then run this program. And it works without any issues. So on the surface, you can see the code for the ArrayList and LinkedList looks exactly same, except for minor changes. But internally, they have different architecture and have different implementations. Also, I can change this linked list to a vector as well. And it would still work. Now that we have seen how an array list, linked list, and vector works in Java, let's try working with a stack. So for that, I'll remove this part of code and type in var, then name of the stack, that is stack in lowercase, then new stack, and then terminator. So here I have a stack of objects. To add elements into this stack, I simply need to type in stack dot push, then the value of the object. So I'll type in 12 and then 23 and finally let's just say a string cat. Now I can iterate over each object of this stack by typing in var s, then stack, then simply typing in s. Now if I run this program, you can see I'm getting all the objects back, that is 12, 23 and cat. But if you remember, a stack follows a last in first out approach. So if I remove an element from a stack, I need to use stack.pop function. And when I use the pop function, it should remove the topmost element from that stack, that is cat, because the first element that we entered into it was 12, then came 23, and at the top was cat. So if I run this program, you can see it only outputted 12 and 23. So in stack, you can't randomly delete or remove elements or insert them. You have to follow the last in first out approach. Now you might be wondering, when do we use stack in a real life problem? So if you're creating a system which requires a undo mechanism or function calls, or writing a backtracking algorithm or expression evaluation, or even creating an application that keeps track of browser history, a stack can be useful. As always, we'll end this video with a quote that says, "Success is not the absence of failure, it's the persistence through failure." Thank you for watching and have a great day.